All right, hi everyone. So today I want to share how I taught myself Elixir coming from a front-end focused background. So before I begin, my name is Lauren, as you just heard. And when I'm not playing Overwatch or video game, I sometimes code. I'm an engineer at Netflix, and I work on applications that our creatives use to produce Netflix originals. So right now we're actually exploring Elixir in one simple microservice. So come speak to me later after my talk if you're interested in what we're up to. You can usually find me on the internet as Sugar Pirate or Twitter, on GitHub as well. And I find starting off a talk with a picture of my dog helps disarm the audience and makes me look more relatable, I guess. So this is probably the best slide of my talk. It's all downhill from here. And here's my dog in the office where she sits next to me. Okay, now that you're all sufficiently disarmed, let's continue. So anyway, I guess I should start from the beginning. My first experience with the web was in high school. My dad gave me a pirated copy of Photoshop, and I spent hours of my childhood making avant-garde lens flare art, some real cutting-edge stuff at the time. Some of you might recognize this photo from the latest Star Trek movie. As a side note, this is actually one of my favorite quotes from that movie, which is also why I started off this section by saying long time ago in a galaxy far, far away, because that's as we all know, it's a great Star Trek quote. Anyway, I learned a lot about design and the web by tinkering around with it, and I learned mainly from tutorials and forums that I came across online. And the very first time you visit a web page and then you right-click and view source, the very first time you do that, it's kind of a magical feeling. You feel like a hacker almost. And in hindsight, without pirated software, I'm not sure if I would have ended up in this career. Not that I'm advocating pirating software. And even though I couldn't afford the real thing back then, software licenses and subscriptions are a lot more affordable now. And I think that's really, really great for lowering the barrier into tech and ensuring our future generations can also enjoy this same thing that we do. And of course, I also learned HTML and CSS from my friend in high school. The first thing I learned was how to use the marquee tag, which in my defense was also quite cool back then. And fast forward many more years, I went to college, I founded a startup, and I started doing front-end work more seriously. I started learning JavaScript and especially enjoyed the functional side of things. For example, being able to use map, filter, and reduce is quite nice in JavaScript. These return new arrays, so you never actually mutate the original array. And I would say that JavaScript is actually a really good language to learn basic functional programming. So for example, functions are first class, so you can write higher order functions pretty easily. And you can also make use of things like lambdas and closures, which are all really nice. And I also explored libraries like Ramda and Lodash, which allow for more functional approaches. So all in all, I would say I actually had some experience with functional programming prior to Elixir. And honestly, the best way to get started learning Elixir or any other functional language on the Beam is to be familiar with some of these basic functional programming concepts first, perhaps in the language that you already know, like JavaScript. And speaking of JavaScript, it's not actually such a bad language. I know someone mentioned they don't like it, but it's used in spacesuits, so it can't be that bad. And after founding my startup and not really getting too far of it, I got another job, and I started building an application in Rails and Ember. Learning Ember specifically was pretty difficult back then. The documentation was very poor, but it's improved a lot since then. And they were actually my first introductions to MVC. So I learned a lot of new concepts working in Ember, many of which translated very well into server-side development. And after working on a Phoenix project for my last job at Dockyard, a software consultancy in Boston, I realized I could also bring some ideas from Elixir into the front end. So for example, if you use Ember, a JavaScript framework, then you can use this add-on called Ember Changeset, which brings in Ecto change sets into Ember, so you can work with client-side models with validations, rollbacks, and a really nice API to make changes to these client-side records. And it's been such a great experience learning Elixir, and I think the more I use Elixir, the more I want to actually write it everywhere. So that's been really great. And of course, React was also a really great introduction to learning functional programming. And Elm, which has a really nice, strong and static type system. So with that, let's move on to the main part of the talk. Let's look at what we're discussing today. First, we're going to talk about Elixir. It's important to start with the basics. Then we'll look then we'll look at how to understand Phoenix and write applications the Elixir way. And finally, we'll discuss the temptations of bringing object-oriented programming into Elixir. I think that's probably one of the most common issues when you first learn Elixir. So first, Elixir. Obviously, before you even dive into learning anything like the OTP or Phoenix or whatever other framework, you should have a strong grasp of Elixir basics. And I'm going to cover these things that I think are important to know and try to explain them as simply as I can. And Elixir is a wonderful language. That's why we're all here today. And every time I use it, I wish I could write it anywhere. But the more I use it, the more I realize that it's not just sugar on top of Erlang. So a lot of the power of Elixir reveals itself when you learn how to use OTP, which is the Open Telegram Platform framework implemented in Erlang. And in Elixir, there are actually a lot of interesting ways of solving distributed problems. So one thing that was really cool at ElixirConf last year, Jose debuted this library called Flow, which is built on top of GenSage. So that's really interesting. OTP is really incredibly powerful, as I'm sure many of you know. And once you're familiar with these basics, I definitely recommend checking out these two books, Benjamin Tan and Sessa Jurik's books on Elixir, and they also cover how to use OTP. So first, let's look at how to learn Elixir. The feature that you probably are going to be introduced to first is the pipe operator. And here's the super simple example. The pipe operator lets you write this, like this, where each pipe passes the value from the previous function to the next as its first argument. Now, it might seem like simple sugar, but it's a little bit more than that. I think one of the obvious benefits is that it actually sets you up to writing your code in a nicer, more composable way, which also happens to be easier to test and reason about. But yeah, it's not just about sugar. It enables a very elegant way of transforming data in composable manners. And it also allows you to nicely handle happy and unhappy paths. And when you combine the pipe operator with pattern matching, it becomes even more powerful, and you realize that you almost never need to use a conditional like if statements. And when I was first learning Elixir, I would have to say pattern matching was one of the hardest concepts for me to grasp. But once you get it, it's really intuitive, and now I wish every language had pattern matching. So yes, thank you, Elixir. And yeah, with pattern matching, you almost never need to use conditionals. Instead, you can just define different function heads to handle different kinds of data. And this forces you to think about your data first. What are the possible values this function will receive, and how do I want to handle them? So here's another example where we have a plug using a case statement to match this arbitrary currency option. So while this is fine and works, you could also write it in this way with pattern matching, which in my opinion, I think this reads a lot better. It's more explicit about what this function does. It's also obviously a really nice way to map input to another output. So here's an example of a controller in, a webhook in Phoenix, where you might want to respond to an incoming webhook, and you might want to then send some email to a user based on the topic of that webhook. So pattern matching, you can very easily just map the topic to an email subject, for example. Another thing you will definitely be introduced to when you first learn Elixir or functional programming languages in general is recursion. So recursion is a really powerful tool, especially when you deal with things that are like tree structures, or if you need to reduce values down to a single value and so forth. So let's go through a simple example. Let's say we have some JSON, and we want to just flatten all of these nested objects into one flat JSON, a flat object. And let's just say like this arbitrary constraint that maybe this shape of this JSON is arbitrary, and you need to be able to handle deeply nested objects of various depths. So recursion is a great fit for this kind of problem. So let's write a simple Elixir module to flatten some JSON. So here's the entry point to our function. Let's assume that this JSON's already been parsed as a map with string keys. So first, what we want to do is we will convert the map into a list. And in Elixir, this is actually a linked list. So the reason we do this is that Elixir has a very nice way to pattern match on linked lists. And when you create recursive functions, it's usually helpful to start with the base case first. The base case is where the recursion terminates and optionally returns value. Without base case, you will get an infinite loop, which is probably not what you want. And in this case here, the base case is that if the recursive function receives an empty list, we will just return this accumulator, which at this point in the recursion is a completely flat object. So we know that our recursive function will terminate, so we actually need to build up the accumulator first. So here we're going to just pattern match on the linked list, and the idea is that we want to, if the value of this, the current value is a hash or a map, sorry, then we want to convert that into a list as well, and then call the recursive function again. And then now we'll just need to handle a case where the key value pair is not an object, and in this case we'll just add it to the accumulator again, and we pass it along to the recursive function. And that's going to keep on going and going until we hit the base case, and then we're done with recursion and we receive our flattened result. And breaking it up into smaller steps help you build your recursive function in a more straightforward way. And then here is a super concise version. I would have to say, as a personal experience, that recursion for me usually does my head in, but I found like doing this in Elixir was a lot easier because of pattern matching. And coming from the front-end world, where sometimes you have to deal with tree structures like this, if you had written this in JavaScript, for example, it would have been full of if statements, and like it's just not very elegant or easy to read. So now in functional programming, we like to think about transforming data, and there are many kinds of data types in Elixir. So let's look at the ones that deal with key value pairs. When data comes from the outside of your application and you need to represent it with some kind of dictionary, you want to use a map. So for example, if your API receives a JSON string that you want to parse and then use in Elixir, you should always convert it into a string keyed map. And this is because if you're new to the Beam, that atom keys are actually atoms. And because Erlang has a default max atom table size of about 1 million, I think, and that atoms are not garbage collected, if you actually dynamically create atoms, you will crash Erlang and pretty much everything running, which I'm not sure if you can recover from. So generally speaking, if the input doesn't come from, if the hash is the keys don't come from you, you don't want to use atoms. And when you do have to create one-off maps that you use internally, then atoms are a great way to create these kind of maps. But this could actually lead to the map becoming just like a free-form bag of data where you just put random stuff into it, which is not always the best and makes things very hard, less explicit, and it makes pattern matching quite difficult too. Structs instead are typically better since it can actually make things more explicit. So as an example, if you've used Ecto, the schema that Ecto provides are actually just structs under hood. And structs are tagged maps with a weak schema. So they're really great for pattern matching, and they ensure at compile time that only the specified keys are allowed to exist, among other things. So here let's do a quick example where we define a function that pattern matches on the struct. You can almost think of it kind of like type checking. And here we have two very simple structs, and the modules that back them pattern match on the different kind of struct. And this team struct at the bottom is a simple abstraction that represents a collection of employee structs. And then we have functions in these modules where we can raise a single employee salary, or we can raise all their salaries by a percentage, which is great. So in your function, you can actually be sure that it only works with a specific struct. So you can actually ensure that the values that are being passed into these functions are the things that you expect it to have. And then, of course, we have tuples, and these are very common in the standard library. And even more so, again, when you combine with pattern matching. So these are all, pretty much most of the Elixir standard library will return you a tuple of some kind. And then the nice thing about them is that in Elixir, there is this with keyword, which lets you work really nicely with tagged tuples. So the nice thing about this is that you don't necessarily have to make your functions directly pattern match. You don't have to directly pattern match on the tuple itself. You can just extract the value with the with keyword over here, and then you can just use it like that. So you're not forced into only pattern matching against tuples. And then finally, there's also a special kind of tuples combined with a list known as a keyword. And these are generally just used as options for functions and so forth. And generally, they're not really recommended for any other use. Now, speaking of structs, one thing really cool about them is that you can define protocols for them. Structs combined with protocols are a way to achieve polymorphism in Elixir, which means that you can act on something in a generic way without knowing exactly what it is. So from the team struct example before, let's build it up with a little simple protocol. So first, let's define an implementation of this count function for the team struct so we can see how many employees belong in this team. And you can do this using the def implementation keyword inside of the body of the module. And now what happens is that you can actually use the standard library, the enum module count function on this struct, even though it's not really it's not a list, for example. And if you define all the necessary implementations for an enumerable, which is count, member, and reduce, then your team struct or whatever other struct that implements these functions, they effectively become a kind of enumerable, even though they might be structs. So let's take it a bit further and we actually fully implement this enumerable protocol. The member implementation here, if you return error in a module, in a tuple, then it's just going to use the default membership algorithm that Elixir already uses. And then the reduce implementation at the bottom is pretty much a copy-paste of the source code, so I didn't want to write my own reducer. But what this means is that now you can actually use all these enumerable functions on your struct, which is really nice. Because if you attended the last talk about libraries, about you designing software libraries, then one of the recommendations was to make use of the language features. So I think like if for example you're writing a library where you have a struct that represents a collection of things, then if it's an enumerable, if it's a kind of enumerable, then it means that consumers of your library can actually use regular language features to interact and deal with that struct instead of making custom special functions that have to do that. And the really nice thing is that you don't have to implement every single function of the enumerable to make it an enumerable. So the only three that you need to implement are count, member, and reduce. So let's say we had a function on the team module to promote all the employees inside of it. So the previous implementation, you actually had to know what the struct, the internal structure of the struct looked like. But now that it's an enumerable, you no longer need to care about how it's internally structured. So again, if you're working with a collection of things, then it's really nice to be able to just use regular language features to interact with this. While protocols work with data types like structs, behaviors are a way to specify an interface for callbacks in modules. So let's say we wanted to validate some data that comes in from an external request. So let's start by using a really simple struct to represent that request. And then let's just say we wanted to validate that this request is in some kind of structure that we expect it to be. And so to do this, you might want to write a validator. So here we might validate that some value on this request is a number, it's present, and so forth. And in this validator module, you can actually define behaviors using the @callback, @macro callback, and @optional callbacks. And now in your actual validator logic, you can implement one of these actual validators that must implement that interface that you just defined. So here's a super simple implementation of the present validator. And you essentially just have to implement all of the non-optional callbacks that you defined in that behavior. If you don't, then you get warnings when you compile, but you don't actually get compiler errors. But if you run Dialyzer, which is a static analysis tool for Erlang, then you can actually at least you can check to ensure that this callback was implemented correctly. And it's also really straightforward to get Dialyzer working with an Elixir project. There is a wrapper around Dialyzer called Dialixir, which is pretty straightforward to add to your Mix project. I think sorry, typo there. And then using type specs as a tool to do static type checking can be very useful, and it helps you catch errors before they happen. And there's a really nice blog post at the bottom of the slide that shows an example of test-driven development using TypeSpecs, which is a really interesting read, so I recommend checking that out after the talk. And finally, I wanted to look at macros. I think one of the coolest features, coolest and probably easiest to abuse language feature of Elixir. Metaprogramming in Elixir is a first-class citizen. And if you're not familiar with metaprogramming, it's code that writes code. Obviously, that's a very powerful tool. And as an example, libraries like Ecto provide a lot of macros that give you a nice domain-specific language to create SQL queries. And Phoenix, for example, also provides you a nice DSL for using, for matching different kinds of requests in its router. And you may or may not know this, but Elixir is actually written mostly in Elixir as macros. When I first realized this a while ago, I was a little confused, like how can you write a language in itself? How does that even work? Well, it turns out Elixir uses a compiler technique known as bootstrapping. And the bootstrapping here happens in Erlang. And then the bootstrapping is actually used to just define primitive macros that make up Elixir. And it only understands the basic building blocks of Elixir, and then you can actually start writing Elixir in Elixir. And these include keywords like def, defp, defmodule, and so forth. And yeah, so it's actually really interesting going through the Elixir source code because it's actually very understandable because it's all written in Elixir, so that's really nice. So here's an example where we have a module known as kernel special forms in the Elixir source. And this module essentially just defines the basic building blocks of Elixir, like maps and list literals and like all these little language features, and it protects them from being overwritten by other macros. And then what happens in Erlang is that it will actually call the relevant Erlang module to create whatever it is that is being invoked. So as an example from before, your map literal, that percent curly braces, it will get passed through here, and then we'll create the Elixir map, and then the other function at the top is responsible for updating maps. And you probably already know that you can call Erlang modules in Elixir, so you don't have to reinvent the wheel. Just by calling the module with the name as an atom, you can access them. And then you can also see for yourself that the Elixir map literal is equivalent to a regular Erlang map. So you actually know that that's what they are under the hood. Although for a while before they weren't, but now they are. All right, so now let's try making our own really simple, really silly macro. So there's this command line utility called calsay. I'm not sure if people here know it. But basically it's a very silly command line tool, and what it does is it takes some text as arguments, and it just returns a little ASCII picture of a cow saying what you said. So let's just, for fun, let's just make a silly macro that does that, just for learning purposes. So here, you'll notice at the top, we defined a macro called using with double underscores, also known as dundescores. I learned that pretty recently. And that gets called when you bring in the module when you bring in this macro into another module. And then what happens is the macro will actually define the function on that other module at compile time. So now, if you use this calsay module in another module, then this macro will get called because of the use keyword, and that will define the calsay function on your module. So now you can call bob.calsay even though it's not a function you defined yourself. And you can probably see here how this is probably pretty easy to abuse. It's if you include a lot of macros in your library, for example, and you don't include things like like documentation or behaviors or things like that, then you get these magic functions that appear on someone else's module, and they have no idea where it came from. And of course, yeah, it does work. So it's a silly example, but hopefully it shows you how powerful macros can be. And I didn't really go into too much detail on them, but if you're interested, please read Chris McCord's book. It's a really great book about macros, and very interesting read as well. All right, so that was a whirlwind tour of Elixir. So now we know Elixir 100%. We can write some web application, right? So let's learn some Phoenix now. I titled this section "Phoenix is not Rails" because I think a lot of Rails programmers actually are trying to learn Phoenix because of the similarities in syntax. But one of the things that a lot of people trip up with is that thinking that Phoenix is a kind of Rails. But the only similarity between Phoenix and Rails is the syntax, and it starts and ends there. That's the only thing that's similar about these two frameworks. And it's really good to start with a fresh perspective, especially if you go from an object-oriented language to a functional language, and I hope this section will help that. So once you're familiar with the basic building blocks of Elixir and the general understanding of the concepts that functional programming encourages, then Phoenix is a lot easier to pick up because it builds upon them and then expands upon them. So let me use a really simple Phoenix API as an example to explain what I mean. So Phoenix is mostly made up of pipelines, and a pipeline is composed out of plugs. And that's, mostly out of plugs. I'll get to that in a little bit. And one of the main bits of Phoenix is this little module in your application called endpoint, and this is responsible for receiving connections, parsing requests, adding headers, sessions, and so forth. And then this connection is handed off to your Phoenix router, which routes that connection to a controller action. Then your controller does its thing and then passes the connection to a view or even halts it if something went wrong. And then your view will perhaps prepare the connection for rendering as JSON or something else. So here's a simple diagram to illustrate what I just said. It starts at the endpoint, then the router, then the plug pipeline, and then controller and a view. And optional side effects if you, for instance, you need to persist something to your database. And if you really zoom out and if you think a bit in an abstract terms, then you can even think about Phoenix like this. It's obviously more than just like this function, but the idea is kind of similar. So that's a really nice functional way of thinking about Phoenix or web applications in general. And remember, Phoenix is not your application. It's only the web component of your application. So basically, Phoenix is a pipeline made up of smaller pipelines and functions. Many of these are plugs, which I'll get to pretty soon. And then the smaller bits are functions that you define in your application, and you can think of these like as the lower level operations. And with Phoenix, we have a very functional way of building an application. Everything is a function, and everything's very explicit. There is no magic in this framework at all. And once you realize this, it becomes kind of simple and straightforward to reason about. And you can always just look at the stuff in the application itself to understand what is going on. So plugs, I mentioned plugs, and these are one of the core abstractions that Elixir's standard library provides to you. A plug is a direct interface to an underlying web server. So if you're familiar with Ruby, plug is kind of like rack, but not really, because with plug there is no concept of middleware. There's only plugs. The only concept in plug is a plug. And there are two kinds of plugs. So this is a function plug, which takes in a connection and some options. And the contract of a plug is that it also has to return a connection. And in that way, you can actually you can pipe plugs together because they all receive connections and they output connections. You can also have a module plug that implements these callbacks in it and call. The call itself is just that function plug I mentioned before, and you can also set options on this thing through the init function. So yeah, this is a very simple but powerful contract. And writing plugs becomes very easily once you're aware of this contract, and you can make use of them not only in your router, you can actually also make use of them in controllers or anything else that deals with connections. So here, this verify request signature function, plug, will be called before any action that's handled by this controller. You can even add guards for the plug, so it's only called for specific actions, or you can do it in whatever other way. And plug pipelines in the Phoenix router are very composable. For example, let's add another pipeline for our API to follow another spec. And you can just literally just add it to this pipeline, and it will start using that in your application. Then as an example for that, let's just make two scopes in our router. And the V1 scope at the bottom is nested inside of this API scope at the top. and then we have this public route called foo. And the foo route will only go through this JSON API pipeline at the top, while the user routes at the bottom will also go through another pipeline called authorize, where you might do some authentication and so forth. And remember the endpoint module I mentioned earlier? If you look at it, it's actually just a really big plug pipeline. It just plugs everywhere. So like logging, JSON parsing, adding headers, session information, everything happens here before the connection even hits your router. And would you be surprised if I told you that the Phoenix controller is also a plug? And so in some sense, Phoenix is fractal, or in other words, each part of it has the same characteristics as the whole. Okay, let me zoom out a little bit. So a while ago, I wrote this blog post about using Phoenix to incrementally replace existing APIs. Terraform has no relationship to the HashiCorp product. It was a poor naming decision. Okay, but anyway, committing to a full rewrite is a really difficult, expensive, and disruptive task, obviously, and probably not the best use of your time. But if you could do it incrementally, one endpoint at a time, then you could perhaps make the case for trying out Phoenix without having to get significant buy-in from anyone else. And you can then see for yourself if a rewrite is worth it. And now that we know how Phoenix works on a relatively high level, it should be kind of straightforward to figure out how to do this. So I'm going to walk through how I built this little plug with an ex-colleague of mine. So we called it Terraform, and essentially what it does is it matches, it forwards routes that you don't handle in your application to potentially another API of your choice. And while it will serve up your Phoenix API if it does find a match. And then so what happens is you can just implement one or more endpoints that you want to replace in your current API and then forward everything else to your old API like a reverse proxy. You can use Nginx for this, but we wanted to try it out in Phoenix, and it's actually very little code if you look at the plug itself. So when we were building this, our first hunch was to try and just put this plug in the router in the endpoint model that I showed earlier, because that's where we knew the connection would first come into your application. And then in this plug, we would just look up all the routes. This is the initial implementation. We would actually look up all the routes in the router that you define, and then we would see if we needed to forward the request to the real API or to handle it in Phoenix. But obviously, this turns out to be a bad approach because, as evident by these double underscores, we're making use of private API, which is usually frowned upon. And it was also very inefficient because you have to, this implementation, you had to actually check every single request and whether or not it needs to be forwarded. So that was a good first attempt, but we thought we could do better, so we went back to the drawing board. And whenever I get stumped, I find it very helpful to just look at other people's source code for ideas on how they solved that problem. And we had a peek at the source for the error handler plug in the plug repo. And my colleague Dan, he realized that we could actually use the same idea in a plug, which is to only handle missing route errors. And then that's where our plug would take action. And because that was overridable, we could use the same macro, but then just update the catch, this catch to do the forwarding for us. And so this little plug was born. Again, no relationship to the product by HashiCorp. We just chose the name because we thought it was a cool metaphor for incremental rewrites, like transforming an uninhabitable planet into a habitable one, except it's an API. All right, so in the plug itself, we have that using macro I mentioned earlier that gets called when when someone else's installs this plugin uses it. Then we will essentially look for this terraformer option being passed into the macro, which points to a module in the Phoenix application that the person has. And then we store it in a module attribute so we can access it later. This before compile macro then gets run, and we pass the connection in the catch into the terraformer, which is itself a plug. That's one of the contracts that we decided that would be important to ensure so that we could, again, use all the language features of Elixir. So now, if you actually want to use this in your application, you can just use the use keyword in your router and then pass it a reference to a terraformer module using this terraformer keyword. And a terraformer is just a fancy word that we came out with for a plug that handles how the unmatched request is forwarded. And if you use the plug router macro, then you get this really nice DSL for routing macros. So all the things that you might be familiar with, like get, put, post, and so forth, you can actually use these same macros to match and then forward requests to your old API. So you can match a very specific path. You can handle everything for a GET request. You can send it to different APIs depending on the requests. You can add authentication headers. You can do anything. And then whatever the response from that API comes back with will be sent back to the user. So if you want to try this out and you don't necessarily want to use something like Nginx to do a reverse proxy, you can even use just Phoenix on its own to do this. All right, so now let's on to the next section. I think one of the hardest parts about learning Elixir is resisting the urge to bring in object-oriented concepts that you don't necessarily need in a functional language. Before we continue, I want to say that I don't hate OOP. I think it has its use. I've had a lot of success with it. But for my time spent with Elixir, I personally think it's a lot harder to shoot yourself in the foot with a functional language, at least for me. And when I go back to work on something like a Ruby and Rails API, it's often very hard to understand what's going on because it's so implicit. There's a lot of magic that happens under the scenes. And if you've done any OOP, you've probably heard of design patterns. You've probably implemented some of them as well. But it's not always clear, at least to beginners, what the pattern is, what the best pattern is suited for the problem. Sometimes it feels like multiple patterns can solve your use case, right? And unless you have lots of experience, it's easy to fall into the trap of like trying to implement all these fancy patterns because you read a blog post about it, and you end up just misusing these abstractions. And there's a quote I really like about choosing the right abstraction by Sandy Metz. I think this actually applies both to object-oriented and functional programming, but perhaps even more so when you try to attempt to solve problems with OO design patterns. But surprise, there turns out to be design patterns for functional programming too. And it's quite straightforward. So there's this really, really great talk by Scott Loshin. He does a lot of work with the F# language. And the next couple of slides are kind of heavily influenced by his talk. So if you have time, please check out his talk. It's really good. Now, the biggest thing, in my opinion, when you transition from an object-oriented to a functional language is figuring out how to do state. In object-oriented programming, as its name suggests, you encapsulate the state with objects and instances and so forth. And in JavaScript, for example, you might use the this keyword in the context of an object so that you can access values on the object itself. So here's a really simple example. You have a class, it does stuff like greet, report, move. Classic example, you instantiate a class, now you have an object. You can move or greet, report, and so forth. And these methods can actually update the internal state of this object. And in other words, they have side effects, and they are not pure functions at all. And you can obviously do a lot of other patterns like extract logic into a movable class, and then you can do polymorphism and so forth. But in functional programming, instead of doing that, we want to think about data and transforming data instead. And in Elixir, for example, if you really needed to have state, then you typically would hold it in a process, like in an agent, for example. And you can even share this across other processes. But not everything needs to be stateful. And so let's look at a really simple example. Here we have a function. It takes an input, it does something with it, and then it returns an output. This is the main contract of a function. In object-oriented programming, you might use a method on this object to convert it into something else, for example. So let's say you want to convert a banana into a pineapple. But this might blow up because you didn't define this function to pineapple, which, by the way, is a great error message for spacesuits. But what about in functional languages? So we solved the problem with composition. And you can tell that this composed function was built from smaller functions. And one of the really useful metaphor I like to think about with OO is that it tries to model the system and their interactions within the system. While in functional programming, you just think about, like how does my data come in and how do I transform it as it goes along throughout my application. I mentioned earlier that Phoenix is fractal. The same can be said of functional programming. So again, the simplest example is this single function. If you use the value of this function as an input to another function, what you get is a service. So for example, you might make a validator or whatever other service that your application needs. And this is composed with small, like really low-level functions. Now you take your services, you compose them, and then you end up with use cases. So again, in the context of a web application, maybe a user wants to update their profile. And of course, if with enough of those use cases, if you compose those together, then you end up with a web application. A request goes in and a response comes out. It's magic. And if you recall, this is exactly the philosophy of Phoenix. You take connections and you return connections. So hopefully with that example, it kind of makes a little bit more sense now. So to recap, it's always a really good idea to start with the basics first. I know I went through a lot of stuff in a short amount of time, but hopefully if you're new to the language, it has made you curious enough to learn about all these different features that Elixir provides. So as a recap, like pattern matching pipes are super powerful if you combine them. Recursion is something that you most definitely encounter in a functional language. It can be scary, but personally for me, I used to hate recursion, like doing recursion at all. But I think Elixir in functional programming makes it like a lot easier and a lot more fun to deal with. And then we have all these other really nice language features like protocols and behaviors and macros. Phoenix is a pipeline made up of smaller pipelines and plugs. It's pretty much plugs all the way down and very fractal in nature. Plugs are abstractions that wrap connections and return connections, making them very composable. And understanding this actually helped us to create that plug, that Terraform plug for incrementally replacing APIs. And finally, in object-oriented programming, you have state. In functional programming, we think about transforming data. And functional programming is very fractal. A low-level function is composed with other low-level functions to form services composed to form use cases, and your use cases composed to form a web application. You can keep in touch with me on Twitter or GitHub, and you can come speak to me later if you have a question. So thank you for listening. You've all been great.